So in this supplemental video on chapter 10, we're going to talk about composite functions. So what we're going to do is I'm going to give you three different functions, and they're labeled as f of x, g of x, and h of x. So on 1 through 4, this is how they're going to look. This is a new concept. So looking at number 1, we would read this as f of g of negative 3. So how this works is we have to evaluate when the x value is negative 3 first in the function of g, take our value, and then plug whatever we get into the f of x function. So we start with the innermost function. Our innermost function is g of negative 3. So g of negative 3, if I take it and I plug it in, we would plug it into the g of x function. So it would be negative 3 times 3. And that's going to give us g of negative 3, which is negative 9. Now, we take that value and we plug that value in for f of g of negative 3. So f of negative 9, 2 times negative 9 is negative 18, minus 1 is negative 19. So the answer to this is negative 19. So on this next one, we start with h of 7. So let's just do this in our head. H of 7. If we plug in h of 7, what do we get? Correct. We get 50. So if we plug it in, we get 50 for h of x. But now we take the 50 and plug it in for f of x. So 50 times 2 is 100, minus 1 is 99. So this value is 99. Number 3, we have a triple function. Now, this triple function is f of g of h of 2. So we start with the innermost function, we plug in h of 2. So what would you get? Correct, it would be 5. So now, I get that. So what would I get if I plugged in g of 5? Very good. I get 15. And then plugging in 15 to f of x, I would get 30 minus 1, which is 29. So this answer would give us 29. In our last problem, we're not plugging in anything to anything else. We are creating a new function, k of x. And in this, to get k of x, we have to take f of x plus g of x. So that would give us 2x minus 1 plus 3x, which is g of x. And if we solve that, the new function k of x would be 5x minus 1. All right, in the next examples, we're going to use these two functions at the top, f of x and g of x. So these, you'll notice that we have no numbers to plug in. This says f of g of x. So what we do here is we actually take the function g of x and plug it in for the x value for f of x. So we're going to take this and we plug it in for x, and we simplify. So it's going to be f of g of x equals, and we're going to get negative 3 times 2x squared minus 8 plus 7. We simplify, and we get this, negative 6x squared plus 31. And that's our answer. Now, the last one looks a little different, but it's called g composite f of x. So all that means, it's a different way to write this. So this would be the same thing as g of f of x. So now I take the reverse. I take the negative 3x plus 7 and plug it in for the x value in the other function. So that's going to give us 2 times negative 3x plus 7 squared minus 8. So now we take negative 3x plus 7 multiplied by negative 3x plus 7. So we would actually get 9x squared minus 42x plus 49. We now distribute, and that gives us 18x squared minus 84x plus 98, but then we subtract the 8, so we get plus 90. And there we go. The last concept in this video we're going to learn is proving that functions are inverse functions, or proving that functions are inverses. We have to prove that two functions are inverses. And in order to do this, we do the following. The concept is this. F compose g of x has to equal x, and g compose f of x has to equal x. In a nutshell, you take one function, plug it into the other, it has to equal x. You take the other function, plug it back into the other, and bam, it also has to equal x. So let's write two functions. The two functions we're going to deal with are as follows. F of x is going to equal 5x plus 3, and g of x is going to equal x minus 3 divided by 5. So we basically plug them into each other. So the first one says to take f compose g of x. We're going to take g of x and plug it into f. So let's take all of this. We plug it in right here for x. So f compose g of x is going to give us f times, we plug in the g of x function, plus 3. We simplify this. That gives you x minus 3 plus 3, and we get x. So check. That works. Next, g compose f of x. Let's plug in f of x into g of x. We would get (5x plus 3), we're plugging that into the numerator, minus 3, all over 5. So let's simplify. 5x, the 3 minus 3 is 0, and drum roll please, we get x. So what we have just proven is we have proven that these functions are inverses of each other. This last example I want you to try on your own. Pause the video, and I want you to do the example. And then you can hit play to see if what you did is what the answer is supposed to be. So I'm going to first plug in f of g of x, or f compose g of x. So that would give us the square root of x squared plus 4 minus 4 equals the square root of x squared. And then if you take the square root of x squared, that gives us x. And let's do our last one where we do g compose f of x, or g of f of x. That would give us the square root of x minus 4 squared plus 4. Again, all we're doing is taking this value of f of x right here and plugging it into that x. So that gives us x minus 4 plus 4, which then gives us x. This works. Therefore, these functions are inverses of each other.